May June 2021, paper 2, variant 3. Question 1. The diagram shows a plastic rod alongside a ruler. What is the length of the rod? Can I find the length of the rod? Yes, it starts at 2 centimeters, right? Starts at 2 centimeters and ends at 9 centimeters. So the difference between 2 and 9 is 7 centimeters. 4 balls with different masses are dropped from heights shown. Air resistance may be ignored. Which ball has the smallest average speed? The one with the smallest average speed would be the one closest to the ground. The mass has nothing to do with the speed. The mass has nothing to do with the speed. Why? Because we can compare the kinetic energy to the gravitational potential energy, or basically all of the gravitational potential energy would be converted to kinetic energy. Therefore, you can cancel out the masses, and the mass has nothing to do with the speed or with the velocity. So the smallest average speed would be the closest to the ground. A cyclist rides 300 meters up a slope. She rides down the slope in 25 seconds. What is her average speed? Can I find her average speed? Total distance over total time. Total distance would be 300 plus 300, and the total time would be 50 and 25, right? This is the total time. So 600 over 75, 600 over 75 is 8 meters per second. An object on the surface of the Earth. Which statement describes the weight of the object? The weight. What does the weight have to do with? It has to do with the gravitational force. It's not the quantity of the material or the space. It has to do with the gravitational force of the object. Tank shown has dimensions 5 and 4 and 4, completely filled with a density of 1000. What is the mass? Density equals mass over volume, so mass equals density times volume. 1000 times 5 times 4 times 4, right? And they're all in meters. You do not need to convert anything. So this would give you a mass of 80,000 kilograms. The extension load graph for the spring is shown. The unstretched length is 17 centimeters. When an object is suspended, the spring becomes 19.2 centimeters. Can I find the weight of the object? Yes. First of all, I need the extension, right? Can I find the extension? Yes, the extension would be 19.2 minus 17, which is 2.2 centimeters. So from the extension axis, I need to draw a line at 2.2 until I reach the line. And then at this point, I will draw another line. So the load is 3 newtons. A car of mass 1,200 kilograms is traveling along a horizontal road. Total friction force is 1,000. The driving force is 4,000. What is the acceleration of the car? Can I find the acceleration? Yes. Force equals mass times acceleration. But this force is the resultant force. The resultant force, which is equal to 3,000. Right? Driving minus resisting equals mass times acceleration. So you have the mass times the acceleration divided. So 1,000. So 3,000 divided by 1,200 is around 2.5, or it is 2.5 meters per second squared. Object X moves to the right on a frictionless surface towards the stationary object Y, as shown. They make a noise as they collide, and then both objects move to the right. Which equation is correct? Can I find, or can I choose the correct answer? The change in momentum of X is equal to the change of momentum in Y. This would be correct, okay? This would be correct if, okay, if you had no losses. There is some loss due to what? Due to the noise. Due to the noise of the collision. Impulse of force X is equal to the impulse of force Y, again, due to the noise, so it might differ slightly. Kinetic energy of x before the collision would be equal to the kinetic energy of x and y after the collision. Again, this is wrong. The only correct answer would be the momentum of x before the collision, because this is moving, would be equal to the momentum of y and x after the collision. You have to add them together, right? Stream flows out of a lake and down the side of a hill, which best describes the change in energy source. So flows out of a lake and down the side of a hill, down the side of the hill. What best describes the change of energy stores? Kinetic energy. Does it start off with kinetic energy? No, it does not. Starts with the gravitational potential energy because it's moving downwards, right? Gravitational potential energy to what? To kinetic and internal, or gravitation plus kinetic to internal? Hmm. So initially it was kind of at rest, right? Initially it was kind of at rest. And then as it moves downwards, this gravitational potential energy starts to change to kinetic energy and internal energy. So it's B. The energy input to a device is E. The amount of energy wasted is W. Which expression gives the efficiency of the device? Can I find the efficiency? Yes, it is the useful output over the total input. Useful output over the total input. So this is the total input E, and W is the wasted output. Can I find the useful output? Yes, by subtracting. So E minus W would be the total useful output over the total input, and then just multiply by 100 to find the efficiency. A builder lifts 30 bricks from the ground onto a platform 2 meters high. Each brick has a mass of 4 kilograms. What is the work done against gravity by the builder in lifting? Can I find the work done? Yes, I can find the work done. You have 30 bricks, 2 meters high. Each brick is 4 kilograms. The total, okay, total work done would be force times distance moved. In this case, the force would be the total weight. Total weight. So 4 times 9.8, I know it should be 10 because this is an old test. 4 times 9.8 times 30 bricks times the total distance, which is 2. This will give you a number slightly less than 2,400, but you can consider it to be 2,400 joules. A book has a mass of 400 grams. The surface of the book in contact with the table has dimensions of 0.1 and 0.2. The gravitational field strength is 10. What is the pressure? Pressure equals force over area, or weight over area. The weight, mg, can I just multiply 400 times 10? He said that the g is 10. Can I just multiply it by 10? No. I have to convert it to kilograms. I have to convert it to kilograms. So divided by 1000, this is 0.4. To find the weight, 0.4 times 10, which is 4 newtons, divided by 0.1 times 0.2. This will give you a total pressure 200 newtons per meter squared. Diagram shows a tank full of water. The mass of the water is m, density rho, the height h, which equation gives the pressure. Pressure equals rho gh. Rho gh. In this case, he wrote it down as hg or h rho g. Again, it's the same thing, right? The same thing. Do I care about the mass? No, I do not care about the mass. I do not need the mass, right? A liquid at room temperature is put on a metal surface which is also at room temperature. A soon blows gently across the liquid and its temperature decreases. What causes the liquid to become cooler? Due to evaporation, we know, right? Due to evaporation. Bubbles of water vapor? No. The moving air reduces the kinetic energy of all of the particles in the liquid? No. Thermal energy flows from the liquid into the metal? This is not the main cause, okay? More energetic particles in the liquid escape into the air. Yes, evaporation. Very small pollen grains are suspended in water. A bright light shines. What are the moving specks of light? Brownian motion. What happens during the Brownian motion? Pollen grains are being hit by other pollen grains? No, by other water molecules. Pollen grains are being hit by water molecules. Question 16. The liquid level in a thermometer rises when the thermometer is placed in hot water. What causes this? It's due to the expansion of the liquid. I know that the thermometers have been removed, but just for your knowledge that the liquid expands. So this is kind of thermal expansion. Okay, thermal expansion. Student calculates the energy needed to raise the temperature of aluminum block from 50 to 60. He then does an experiment to measure the energy used to do this. Which statement about the measured energy is correct? Which statement about the measured energy will be correct? Let's see. The measured energy will be greater than the calculated energy because some energy is transferred to the surroundings. Is this correct? It does seem correct. Why? Because whenever we calculate something, usually in real life experiments, the values might be much, or not much, slightly less than the calculated numbers. Why? Because of the energy lost to the surroundings. Yes, it's always due to the energy lost to the surroundings. Which row correctly describes a liquid that is boiling? Do we see bubbles? Yes, we do. Where it takes place throughout the whole liquid. 3 students are planning an experiment to test thermal conduction of different materials. They propose a hypothesis. I think the copper will be a good conductor because it's a metal. Maybe. I think the glass will be a good thermal conductor because it has free electrons which vibrate and then transfer energy quickly. Doesn't seem right, right? We know that glass does not have free moving electrons. I think the wooden rod will be a poor conductor because it can only transfer energy alongside the vibrating lattice particles. Yes, this definitely seems correct. So only 1 and 3 are right. Only 1 and 3. Okay, all right. We have a very hot copper plate, a shiny surface, and a dull black surface. Why does the hand near the dull black surface feel much hotter than the hand near the shiny surface? Hmm. Dull black is a better emitter, conductor, reflector, is at a higher temperature. No, it's not at a higher temperature, is it? They're both at the same temperature. In this case, we'd say that the dull black is the better emitter, right? It's the best emitter of infrared radiation. Best emitter of infrared radiation. We cannot say it's a better conductor because he's not touching the surface, okay, nor is it a reflector. Actually, it is the worst reflector. It's not a better reflector. A water wave passes into a region where the wave travels more slowly. What happens to the frequency and what happens to the wavelength? Does the frequency change? As we said, the frequency does not change, so it remains the same. As it moves more slowly, as the speed decreases, what happens to the wavelength? Decreases as well. What is the speed of light in the glass? Can I find the speed of light in the glass? Yes, it will decrease, so I can cancel out C and D. First of all, I need to find the refractive index. N equals. We have two angles, the angle in the air and the angle in the glass. So sine air over sine medium. Sine 55 over sine 33, right? What's sine 55 over sine 33? Let's see. Sine 55 over sine 33. This is 1.5. Exactly 1.5. Can I find the speed? Yes. N equals speed of light in air over speed of light in medium. To find the speed of the light in the medium, it would be 3 times 10 to the power of 8 divided by 1.5, which is 2 times 10 to the power of 8. A beam of light is monochromatic. What does monochromatic mean? Monochromatic means that it has one frequency. One frequency. An object is placed okay, in front of a thin converging lens. Diagram shows the path of the light of two rays. An image is formed. How does this image compare with the object? If the image is formed on the other side, okay, it would be inverted. So I'll cancel out B and D. Is it larger or is it smaller? I need to actually draw, or you can measure the length. Which length would I measure? I would measure the focal length. So this is a focal length. If you measure another distance focal length to this point, it would be almost at this point, which is between, or the object is now between F and 2F, right? F and 2F. And we know that if the object is placed between F and 2F, the image will appear to be larger, right? Okay, what if I do not want to do that? Can I just continue these rays? Yes, you can extend these rays until they meet on the other side. When they meet on the other side, you'd have a larger and inverted image. Which row correctly describes what happens to the frequency and to the speed of electromagnetic waves as we move through the spectrum of from gamma to radio waves? From gamma to radio waves. What happens to speed? Does it increase, decrease? No, it actually remains the same. They all have the same speed, 3 times 10 to the power of 8. What about the frequency? From gamma to radio waves, gamma has the largest or the highest frequency, therefore the frequency decreases, right? As you're going from the gamma rays to the radio waves. What is region Q? So we have some molecules, air molecules. What is region Q? Is it a compression or a rarefaction? Definitely seems like a rarefaction, doesn't it? Yes. Why? Because the molecules are far apart. So it's a rarefaction with a higher pressure or a lower pressure. Again, a lower pressure. Why? Because the molecules, distances between the molecules increases, therefore the pressure decreases. You have a loudspeaker and a microphone, two materials. Which combination of materials gives the shortest time for the sound to reach the microphone? Sound is a mechanical wave which depends on the molecules to travel from point A to point B. So you want the sound to travel the fastest. You want it to take the shortest time. In which medium does the sound travel the fastest? It travels the fastest in a solid. So I need to pick two solids. You need to pick two solids, which would be C. A bar magnet picks up two steel bolts. Which diagram shows the magnetic poles induced in the bolts? South and south, this is wrong. South and south, this is wrong. South and north, south and south is wrong. Again, south, north, and south. Yes, so this is correct. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What has happened to the rod? Positively charged loses electrons. Positively charged loses electrons. Yes. Question 30. What happens to the charges on the neutral sphere as the positively charged sphere is brought close to it? So when you have the positively charged sphere near the neutral sphere, what happens is that the negative charges slightly move to the left, right? The negative charges move to the left, but the positive charges do not move at all. Why? Because the positive charges are the protons inside the nucleus, and we know that the protons inside the nucleus do not move at all. They not they don't move. Only the free moving electrons can move because this is a metal sphere. So the negative charges move to the left. Indeed. Negative charges move to the left, but the positive charges do not move at all. You can actually cancel out A, B, and C, right? Positive charges do not move. Diagram shows a circuit containing a cell, two resistors, and a switch and a voltmeter. When the switch is open, the voltmeter reads 1.5 volts. When the switch is open, the voltmeter reads 1.5 volts. When the switch is closed, the voltmeter reads 2 volts. Again, switch is open, as shown, it reads 1.5 volts. When you close the switch, the voltmeter reads 2 volts. What is the electromotive force of the cell what is the electromotive force of the cell? It would be 2 volts. Why would it be 2 volts? Because when you close the switch, you kind of create a short circuit. What do I mean by short circuit? It's as if the current does not pass through the resistor at all. It actually doesn't pass through the resistor at all. So all of the current passes through this wire, bypasses, okay, that's why we call it a short circuit. It bypasses the resistor, so no current at all can pass through the resistor at this point when you close the switch. And then all of the voltage, all of the EMF of the battery is automatically transferred to this resistor alone, making it 2 volts, and therefore the voltage or the EMF of the battery is 2 volts. Okay, because of the short circuit. What is the effective resistance of the combination of these resistors? Can I find it? Yes, product over sum, right? Product over sum. 4 times 12 over 4 plus 12. It has to be less than 4, less than the least resistor, which would be 3 ohms. Question 33 is cancelled. Question 34, you have a rod, you have solenoid, and as the rod is inserted into one of the ends, the ammeter shows that there is a current in the solenoid, right? What must this rod be? It must be a magnet. It has to be a magnet, right? Magnetized steel rod, right? A 12 volt 36 watt lamp shines at normal brightness when connected to the mains transformer. It's 100% efficient. Which row shows the number of turns in the secondary coil and the current in the mains wire? So we need to solve two questions. We're going to use two different equations. What are the two different equations? VP, okay, VP over NP equals VS over NS. And then we are going to use the other equation, VPIP equals VSIS. VP, if I want to solve for example, if I want to solve for the number of turns first, you have VP, which is 214 and 1200, which is equal to VS 12 over NS. Can I cross multiply? Yes, if I cross multiply to find NS, so NS would be equal to 60. Cross multiplication, NS would be equal to 6. Now, can I find IP? Yes, 240. IP equals 12 times, what is the current? 36 divided by 12, which is 3. So 12 times 3 divided by 240, which is 0.15. 0.15. Okay. Diagram 1 shows a wire uh, carrying an electric current. The wire is between the poles of a magnet. In which direction does the force act after these changes? So we had direction of the force, you had the current. Okay, you need to carefully figure out what happened. You need to carefully figure out what happened. First of all, you had the current into the page, right? In diagram 1, you had the current into the page. In diagram 2, the current has been reversed, so it's out of the page, right? The current is now out of the page. And the magnets have moved. Magnets have moved. Can I use Fleming's left-hand rule to find the direction of the force? Yes, I can use Fleming's left-hand rule. So first of all, you have the magnetic field from north to south pointing upwards, right? Pointing upwards. And now, instead of the current being into the page, it's out of the page, right? It is out of the page. Therefore, the force, the thumb, will be pointing to the left, right? The thumb will be pointing to the left. So the force on it will be towards the left-hand side of the page. It wants to move to the left, right? Fleming's left-hand rule. Charge on the proton is E. What is the electron and neutron? Electron is negative E, neutron is 0. Diagram shows alpha particles incident on a thin metal foil. How does the motion of these particles give evidence for the nuclear atom? How how did we know that there is an atom? How do you know that there is a nucleus inside the atom? That this nucleus is positively charged? Hmm, because of these deflections, right? Because of these deflections. Most particles passing through with minimal deflection show that the atom is mostly empty space. Yes, we did learn that. We did learn that. Most particles passing through with minimal deflection shows that the mass of the atom is uniformly distributed. Is the mass of the atom uniformly distributed? No, it is not uniformly distributed. It's actually concentrated in the nucleus of the atom, which is wrong. Large deflections of some particles show that the atom is mostly empty space. No, this is wrong. Large deflections show that the nucleus is positively charged or it has most of the mass. Large deflections of some particles show that the charge is uniformly, again, the charge is not uniformly distributed. The charge is concentrated inside the center, inside this nucleus. Hmm. Radium is an alpha emitter. It is implanted inside a cancerous tumor, inside cancerous tumors. Okay. It is safe to use it because it kills the cancerous cells, but not the healthy ones surrounding the tumor. Which properties of alpha particles compared to other emissions enable this use of radium? The ionizing effect, is it high or low? We know that alpha is high. The penetration, is it high or low? We know that it is low. That's it. That's all you need to do. That's all you need to say. What is the half-life of this source? Initially it was 120 divided by 2, which is 60. Draw a line. So the half-life is 2 minutes. Okay.